Dear students and participants of the course on railway engineering, now we are going to start with a new module. In this module, we are going to talk about the track alignment, the speeds on tracks, the cants and super elevations, the vertical curves. That means all of the geometrics which are required to lay any track or for the movement of the trains on that particular track, whatever are the prerequisites, those are the things we are going to discuss in this module. Now, in the previous module, when we were completing it, we talked about the fastenings. The first fastening which we have taught was the rail to rail. The another one which we discussed was rail to sleeper. And in this, the conventional as well as the elastic fastenings were discussed. The fastenings were discussed with respect to the type of sleepers also, because they are different type of sleepers which are in use and on which the rail is being seated. In today's discussion, we will be talking about the track alignment. The track alignment means whether we are having a straight section or we may be having a curved section, or there is a possibility of multiple curves which are coming on any of the alignment which is being provided between point A and point B. So, when we have to fix this alignment, what are the requirements which needs to be looked at, which needs to be satisfied? That is one another thing which we will be discussing in this particular lecture. And then finally, how a profile is selected, what are the various factors which are considered for selecting a particular profile, as I said, between a point A and B. That is the another point of discussion in this lecture. Starting with why alignment need to be fixed. As I just said, we need to connect point A with point B. Now, this connection, when we are providing, maybe in the form of a straight line, it may or may not be possible, because in between these two particular locations, the topography may be different. It may happen that it is a totally a plain area, or the terrain in this particular one is undulating terrain, or the undulations are even very severe, or there may also be a possibility that some other feature, say a river, is lying in between these 2 points, and therefore you have to cross this river. So, the very first thing is that we need to connect different locations. Now, when we are trying to connect these locations, why we want to connect A and B, why we are not connecting at this moment A and C, that is also an important issue, and that is where the different purposes will come into picture. As being written here, it can be a strategic condition, industrial condition, or it can be a consumption center, or it can be a very big habitation which needs to be connected because of the flow of the manpower from that location to another locations, or from other locations to that locations. So, different reasons can be there due to which those connectivities needs to be provided. Another issue is the development of an area. Now, if this area which is being governed by the location B is not being connected with A or C or any other such locations, it is being made as remote, then what will happen with this particular area? There is no information regarding how the things can be developed, there is no information regarding how the world is progressing. So, this remote area will not develop, and one of the reason why we need to provide the various types of connectivities is to develop that area. And of course, this reason, that is the movement of persons and goods, is the core of transportation. So, if we talk about transportation definition, what you will say is that transportation is the movement of persons and goods, and the same applies to this rail track and alignment or the rail connectivities or the rail networks which have been provided in a local area or a region or at a national level. So, there are reasons that we should go for a alignment fixing. We should go to try to identify what should be type of a profile which needs to be provided between the two locations. So, considering all of these points, which are basically you can say the broader points that why the things needs to be done, we are moving forward with this particular understanding. So, when we say there is a purpose and it is a strategic or a political purpose, now we have the border areas, and those border areas for a certain period, or you can say for a long time period, even you can define that they have been connected by a road system. And even there are some areas where even the road is not there and you have to provide the air connectivity. And all of these areas, they are in the border regions. So, strategic requirements are there. You have to move the army, the armed forces, you have to move their equipment, you have to move the manpower to those areas, you have to move their requirements to those particular areas. So, this is one strategic reason which can be there, so as to provide a connectivity, and that can be one of the purpose. Now, the emphasis has now been given to connect all those border areas, and some of the examples have been talked here. Say we are talking and working on the rail network in Jammu and Kashmir beyond Jammu, and there are certain areas in which it has already started, and then further extension of those lines is going on. So, if we talk about the northeast is being considered as the most rugged area with lot of mountains and valleys, and the connectivities have been provided previously to Guwahati, Siliguri, those particular locations only. Now, the projects have been taken up which are talking for the providing the connectivity, say from Balupong to Tenga and then from Tenga to Tawang. So, this is in Arunachal Pradesh. So, if those connectivities comes, then the connectivity up to Tawang will be there, and this Tawang is very nearer to the border line with respect to the China. Similarly, Silapathar, Assam to along via Baim, Arunachal Pradesh again. So, this is again on the border side only, or Rupai in Assam to Pasighat to Arunachal Pradesh. These are some of the examples which have been taken up with strategic or political reasons. In fact, when we talk about this political reason can also be with respect to the areas which are being represented by certain MLAs and MPs, and they want to provide a connectivity to their constituency. A better connectivity is to be provided. Say there has been a narrow gauge or a meter gauge, now it has to be converted to the broad gauge, so that the movement becomes faster, more of the loads can be taken to that area. So, that can also be one of the reasons that we start working with those particular aspects. Connecting employment centers with the adjoining workforce centers. There are a number of examples where one of the big city, say if I talk about Mumbai, there is a lot of traffic which is coming to Mumbai from Pune, from Surat, and similarly from different other areas also, because Mumbai is one of the commercial capital of our country. So, when all of this flow is there, and if the connectivities are not being provided between all of these locations, then how the people will move? And Mumbai being a costly city as far as the living is concerned, people may like to stay in Pune or Surat, and they may be traveling for 2 to 3 hours from those respective locations to their area or the location of employment, and that is the type of connectivity which is required. Say when this particular type of movement becomes much more, then it is always better that instead of these 2 hours or 3 hours, if this can be reduced to a lesser value, is also a good thing for the country, because lot of time which is being wasted if you convert into the GDP of the country, because that is a time which is not being utilized in the production condition. So, there we need to have some other type of a network, say a high speed rail. You must be knowing that this high speed rail work is going on, and we even talked about this when we started this discussion on railway engineering in the very first lecture. So, these high speed rail development is going on between Ahmedabad and Mumbai, and even that these two locations Bangalore and Mysore. Here also the flow is there, and therefore, there also another sector or a net track which is going to be connected by high speed rail. Similarly, one another connectivity where a lot of people move between the two places, that are two cities here, Delhi and Meerut, they are going to be provided with the regional rail system. So, regional rail transport system is coming up. It has already come up for a certain section, but some section is being left. Maybe it is going to be over in the coming months. So, this is another purpose with which we are going to provide the connectivities. Now, if you say that Delhi Mumbai, Delhi Meerut, RRTS is coming on, was there no connectivity before? There was a connectivity of the conventional rail. There is a connectivity by road also. A very good expressway is there between these two cities, but when this RRTS comes up, the distances are further going to be reduced in terms of the travel time. Then another is the connecting trade and consumption centers. Now, this trade and consumption centers, say we can also say this trade can also be a production center. So, there are textile units in a particular area, but obviously all of these textile which is being produced here, it is not going to be used by the people in that area only, in that city only. So, it needs certain locations where this can be consumed. So, if we know what are these locations where it can be consumed, so that defines that the trade will start between these two locations. So, there is a requirement to provide this type of a connectivity. And looking at this aspect, that there is a requirement to connect all the consumption centers along with the production centers, and the trade has to be improved, the business has to be improved, and then only the economy of the country is going to be further boosted. Number of sections have been identified by Indian Railways, and here I am giving an example here like Jaipur Savai Madhopur, Luni Samdari Belri, Akthori Kamakhya, Motumari and Vishnupuram. So, these are different sections which have been identified for the development, and they are in the process of development only. And once they are operational, now the trade in those areas is going to further get a boost. In some of the cases, it may happen that by providing this type of a connectivity, we will connect them with the main line. Say we talk about Delhi and Mumbai. So, there is a main line, but there will be some other locations, see another city here at the site, which requires to move some material to Delhi or to Mumbai. So, that connectivity if it is being provided, as soon as it happens, now this location was already connected. So, the another city is connected here, and that is where the connectivity or this processor of movement of the material between larger area will get started. Development of the backward area or the remote location. Now, in this case, Again, the point comes that first of all you need to identify that what are those backward areas where the various types of things which otherwise people have observed in a city environment has not reached. Say, I have taken an example previously like of northeast India. There are many of the locations in the northeast India which are not properly connected, and the main connectivity is through the road, and then it is a very circuitous road because you have to follow the contours of the terrain, and it takes a lot of time. It is very exhausting, though you will be able to see the beauty of that area, but yes, there are certain travel problems. So, rail lines have now been provided to that particular area. Similarly, as already discussed, in the case of Kashmir also the rail lines have been provided, and the connectivities are going on further. And even in some of the locations where there was a problem, a very good bridges have been constructed, say on Chenab, which is one of the highest bridges. So, these marvels are also going to be there when you start developing an area. So, it all depends on the thought process, it all depends how the things have been designed. I can take another example which is providing connectivity beyond Rishikesh in Uttarakhand. So, in Uttarakhand is known for Char Dham Yatra. So, people are coming from different areas, but then they have to get down maximum at Rishikesh. There is no further connectivity in terms of a rail network. So, what government has done is that they are trying to provide a connectivity, say to Karnaprayag, and as soon as this will come, a very big area in the hilly region is going to be connected to it, and the development which has not reached to that area, it will be able to reach there. People will be able to enjoy the benefits of those developments, and the overall prosperity will be there. So, connecting a tourist location, many of the networks which are already available in our country, say if you talk about the Nilgiris railways, where the connectivity has been provided to Ooty or Uttarakhand. So, this is one of the very beautiful rail line where you take somewhere around 3 hours of a journey, and you can see all of the terrain, the cities beyond at certain distances from that particular track. The Kalka Shimla rail line, this is also one another such connectivity which has been provided, considering that Shimla is one of the big tourist place. So, up to Kalka there is a broad gauge network which is coming, and then from there the hill gauge or narrow gauge goes to Shimla. Similarly, Darjeeling railways, this is also one of a beautiful railway. It provides a connectivity for Darjeeling from the plain areas, Siliguri. I was talking about Rishikesh Karnaprayag, and as I said that this is also going to look at the Char Dham. So, the connectivity to Char Dhams in terms of when you are reaching up to Karnaprayag, then the Badrinath will be not far off, and between Rishikesh and Karnaprayag there will be number of stations, and again they will provide a connectivity from that particular location to Kedarnath or Gangotri or Yamunotri. So, the travel by road will reduce, and as soon as the travel by road will reduce, the congestion on the road which is coming because of this Char Dham Yatra will also get reduced. And at the moment, because of this Char Dham Yatra, many of the big vehicles have to be stopped, the trucks have to be stopped, and therefore it causes problems in terms of the fulfillment of the requirements like commodities, the essential commodities which needs to reach there and not reaching. Then another reason can be shortening of the existing commuting times. Say if we take an example from the central India to the south side, a Konkan rail link has been created along the west coast, and this rail link, it has reduced the travel time. At the same time, it provides very good locations which have scenic beauty, and you can enjoy your travel by moving in a train on this particular link. So, another thing is the speed upgradation. So, speed upgradations are going on. Initially, our trains used to move at a speed of maximum 100 or 120 kilometers per hour. Now, we are moving at 160 kilometers per hour, and we are aspiring to move them at 200, 220, 250, and finally 320 kilometers per hour. So, that speed upgradation will reduce the travel time, and when it reduces the travel time, the overall existing commuting times are be much smaller. Integrated development is also a core of any of the planning which is done, whether it is related to roads, whether it is related to rails, or it is waterways, or it is airways. Integrated system has to be there. So, the rail and road transportation, as I said, that if we are talking about, suppose this Rishikesh, Kanprayag, and we are talking Char Dham, so we are reaching there finally by road. So, it is a combination of rail and road, or it can also be a combination of air and road. So, that combination, that the two of the systems which have been provided, they complement each other, is an important aspect of any of the development in an area. Economic considerations, shortest route. The shortest route always is a direct route between the two places. Sometimes if it is a direct route and it is the shortest route, it may not be feasible. We will be talking about that when we will take up the selection of a profile. Now, being shortest, it reduces the construction cost and the operation cost, as well as it reduces the travel time between the locations. Say if we take an example, you have to travel between Mumbai and Delhi. There can be two ways in which it can be done. One is via Kota, Vadodara, another can be via Jhansi, Gwalior, Bhopal. In one case, you have to travel 1400 kilometers, in another case, the distance will be 1537 kilometers. I talk about the travel time. On an average, it takes 14 to 15 hours if you are traveling via Kota and Vadodara, whereas in another case, it may take 18 hours or more than that. So, that is another issue which can be looked at. And it also results in the low maintenance cost, because the total rolling stock, the total track which is being laid is a shorter length. So, the requirements will be lesser, but if it is a longer length, say if we talk about this Mumbai Delhi via Jhansi Gwalior, then in this case the maintenance cost may be relatively more with respect to the another alternate route. Now, the construction cost, it can be reduced by selecting an alignment which is fairly balanced cut and fill of the earthwork. So, if it is moving into different type of terrain, we need to see that how much cutting is to be done and how much filling is going to be required at any of the location, and if we can just compensate these two things, then it is going to be a good way. Now, minimal cutting in rock strata, now this is a costly affair. If you go for cutting in rock, is costly. So, as far as possible, that should be minimum. Avoiding drainage requirements, because if you have to look at these, if you are crossing these locations where the drainage requirements will be there, so you have to go for any type of thing. It can be culvert or it can be minor bridge or it can be major bridge, and all of these things, they will increase the cost. So, we need to see that if we can avoid these, it is better. The maintenance cost can be controlled by alignment on a steep gradient, avoiding sharp curves, avoiding locations which may cause deterioration. Now, here when we say alignment on a steep gradient, now this has to be basically not taken. You need to avoid here also. It is better that if you move in this form rather than directly going here, whereas you are scaling a big height. So, there will be problems with respect to the wear on the rail head because of the braking, and again the brakings has to be used. The brake forces will be there, heating will going to be generated, there will be flow of the metal. Sharp curves, again In this case also the wear will also be more. We have discussed about those. Avoiding locations where any deterioration can be there. So, you need to remove that. If you can do that, then it means you are going to have a low maintenance cost. Operational expenditures, they can be achieved by providing easy curves, gradients and the direct connectivity. Okay, so just opposite to what we discussed previously. Maximum safety and comfort is another reason. So, properly profiled and designed alignment if it is provided, and when we say profiled and designed, it means we are talking about all those features like curves. Curves can be horizontal curves or vertical curves, and when providing these circular curves there may be a requirement of transitions, there is a requirement of providing super elevations, there is a requirement of scaling the gradients, there needs to be removing of the kinks between the connection of the different profiles. So, if everything is being done in a perfect manner, then the safety is going to be improved, the comfort is going to be improved. Selection of the unyielding formations, because yielding formations will keep creating problems in terms of the maintenance requirements. Safety with respect to the terrain features. The terrain features, you are in a hilly terrain. So, what are the safeties which needs to be taken care of? So, that also becomes an additional feature there. And finally, the aesthetics is one important thing. Whatever the route is being provided, it should be aesthetically pleasant. Coming to the selection now, the very first thing is which gauge should be used. We are going to provide a connectivity from point A to point B. So, there can be a direct connectivity as provided here by this first one, and there can be indirect connectivities as 2, 3 or 4. So, the very first one which we are talking here is that what type of gauge should be provided. We have already discussed about a uniform gauge policy which came in 90s, and there we have taken a decision for Indian Railways that the broad gauge are going to be there. So, we should stick to that and use the broad gauge. Obligatory and control points. Now, when we talk about these obligatory and control points, one point is the important cities along the route, which may be having a political, a strategic or a commercial importance. We discussed about all of these in the case of purposes. So, any such important city which is going to fall on the alignment or near to the alignment, then let us connect that. Say if we talk about this alignment number 2, there is a city C, and this city C is having an importance. So, what is being done, an alignment has been shifted, that means now we are not going direct. So, it is going to be a bit longer, but the C is being connected and then we are going to B. Similarly, it can happen with respect to D. Locations to cross river, bridges, lands and cost, this is also another thing, but you cannot remove river. So, here there is a river and the point A and the point B, they are on other sides of this river and it needs to be connected. That means there is a requirement of providing a bridge. So, a bridge can be here or this one, but when we are doing this, what you can see here is that the alignment has to be placed in such a manner that before approaching the bridge, a sort of a straight connectivity should be there, and then only the train should move on that bridge. And the bridge at that particular location is at 90 degree to the curvature of the river. This is also an important aspect. Passes and saddles in the hilly area. So, in the hilly area, if you are looking at it, so if this is a hilly area, if it is a possibility of moving in this, it is okay, but in this particular one where we have taken up this example, it is not possible because there is a river flowing between that two hill systems. So, we need to identify whether it is possible or not. If it is possible, we use that. Tunnel locations, and this tunnel locations, it helps in reducing the circuitous route. You may be required to move, as I said, in this form, but there may be a possibility that if you are moving from this area, if a tunnel can be created, then such a long distance is going to be reduced. And this improves upon the travel time, it improves upon the overall cost, even the operational cost is going to be reduced in those cases. Then plane and the flat alignment. This is easy for construction and operation because not much dilations are there. So, you are moving at a certain level, and when you are moving at that level uniformly, then the hauling capacity is being utilized to the maximum. Valley alignment is another one which is good. In this case, the what we do is that at plane alignment, if the connecting points lie in the same valley. So, if this is the case, so if you are using this valley alignment and if those points are falling in this one, so what you are doing is you are basically moving at the more or less similar level. So, again this is a easier pattern. Cross country alignment. Now, cross country alignment means it is passing through different levels, it is passing through different type of terrains. There may be a possibility that there are rivers which needs to be crossed, and these rivers or nalas which may be there, they may be of different widths. Watershed locations may be there, that is the water, if we talk, so the water flows in this direction, on this direction, so this is a watershed line. So, if we are moving our track at this point, there is no problem of drainage. And when we are looking at these type of systems, sometimes going up or down, and then there is a possibility that it will increase the requirement of the hauling capacity or the traction which should be there on the locomotive, as well as it will increase the cost. Now, mountain alignment, it requires the use of steep gradients. It needs use of developmental processes. When you are going on a steep gradient, within a short distance, a very high is to be reached. So, in that particular case, some development processes are being defined. We will be looking at those developmental processes. So, here are some examples is being shown. You can see this is a mountain alignment. Alignment is going at the top of a big mountain. Here also the another one example you can see. Now, this length development process in that rugged terrain, there are different methods which can be used. One is like a zigzag line method. Now, in the case of zigzag line method, you can see that if you are moving from this direction to here, the levels are increasing. Similarly, when you are going here, these levels are increasing. It means there is a hill here as well as the hill on this side. We are trying to move in this one, which is between 65 and 65, that means it is more of a plain area, and then a turn is being taken and slowly we have moved to 70. That means slowly we have come to 5 meter level up, and again we are moving in that, and then we find that there is a possibility, and here only in this one the higher traction will be required. So, this is a zigzag movement. It is also a horseshoe pattern. Alignment follows a convenient side slope which may be at right angles to the direction of normal alignment. So, if you have been talked about a direct connectivity would have been like this, and it then turns around by 180 degrees. So, you can see that 180-degree turnings are being provided here. Another is a switchback method. Now, when we are going into a terrain where the distances needs to be crossed, say not distances, even the elevation needs to be crossed in smaller distances, then probably we have to go for it. What we are doing is that, say we are starting from the point C, we are going along. What we have done, we have crossed 1 and then we have come to a location A, but then it is going further. At point A there is a buffer stop, then the train starts moving back and it comes now to B and again goes to the buffer stop and then it goes. So, this is how the switchback method is being used. So, it is used in the hilly area. So, when it is passing through the steep side slopes, then this type of a method can be used. Reversal in the direction of movement is achieved through a switch which is located at a station yard. So, there is a switch which is being located at a station yard, and there are buffer stops which are provided at the end of the switch. So, here the switch is the location where the two tracks are meeting, and then when you are going back there is a buffer stop. The third one is a spiral or a complete loop method. So, in the case of a spiral or complete loop method, this is being done when you found that a lot of difference in the elevation is going to be there is no other way, and if wants to go straight, then this is not at all possible. Even you have to provide 2-3 locomotives, it is going to be difficult to control the movement. So, in this case, as you can see that we are coming say from this side, and then here this is a hill. We have to go on this particular side, but we cannot traverse because these all contours, they are very nearer, it means it is a steep condition. Now, when this steep condition is provided, a tunnel has been made here. So, you can see the dotted line. So, this is a tunnel which is going through the hill, and then you are coming slowly and slowly, you are increasing the height, and then you have come to this location and then moves from the top of the tunnel. So, a loop has been created. So, this is used in the narrow valleys where a small bridge or a viaduct is constructed at a considerable height to span the valley, or line crosses the same point at a height through a railway bridge or a tunnel. Any of the thing can be there. So, here you can see there is an example that this is a lower level and this is a higher level. So, the track which is going, so it is coming from this side, then it goes below and then it comes and goes in this form. Similarly, here also the train is coming from here, this is the upper side, and then it is going from the bottom, and there is a upper level movement is also there. Similarly, in the case of river, you can see, and the river which is being shown by a red in this diagram. So, a train is coming from this side, and then it takes turn and it is scaling the heights, and then finally a bridge is being provided here and it goes back in this. So, it is not that it is going like this directly. Another consideration needs to be taken care of is geological formations. Now, geological formation means we have to look at the strata. The strata should be stable. We should avoid the marshy lands or the weak soils. We already said that the yielding formation should not be there. It should be free of the drainage problems as far as possible. In some cases, if it is not, then we have to construct those extra features. Rocky is stable, but costly from the construction point of view, because if you have to keep blasting it, you have to keep cutting it, it is a costly affair. It should be free of slips and slides. So, these are some of the features in the case of geological formations which needs to be taken care of. Then the effect of flood and climate. Areas which are having less likelihood of flooding is better, otherwise again the maintenance cost is going to increase. In the case of sandy or the hot areas, the alignment should pass through the leeward side of the sand dunes, so that if any of the sand dune is there and you are on the leeward side, so this track is moving here and the wind is moving in this direction. So, this sand will never come on the track. So, track will remain free of the sand. So, the directions of the wind needs to be taken care of whenever the tracks are being constructed in such area. Sunny side is preferred, especially in the valley conditions. In the colder regions, the alignment should pass on the side of the hill which is facing away from the direction of the wind. So, the wind effect, the sun effect, they needs to be taken care of. The snow affected areas, this needs a critical consideration, because if it is been provided, then you have to remove the snow periodically, then only the train will be able to move on it. Then position of roads and railroad crossings, whenever there is a track being provided and the road is crossing it. So, this is a level crossing which we are talking here. The alignment of the two one, they should be at right angle, and that improves upon the visibility with respect to the movements on the two different type of paths. The geometric standards which needs to be taken care of here, the most economical combination should be taken. The straight portion near stations and bridges, rise and fall balancing, we did talk about it. Hauling distances which are governed by the locomotive performance, we have discussed when we talked about the hauling power. Then transition curves, vertical curves, these are the points we will be taking up in this module itself. The geometric elements within the permissible limits, again This is the point of discussion in this module. The gradients, most of the time we work with the rolling gradients. So, the rolling gradient needs to be taken care of, as well as the radiuses if needs to be provided. If it is as flat as possible, when we say as flat, it means the radius should be maximum. And these things, the radius or the gradients, because they causes the resistance, they have an impact on the weight which is going to be moved. Again, this we have already discussed when we talked about the track resistances. Minimum 36 meter of the long chord should be provided if there are two reverse curves. That means if the curve is going in this form, then there should be a minimum 36 meter between the end of the first curve and the start of the second curve. Traffic. The traffic, it is being considered when you are developing, you do not know how many people will travel. So, what we consider as a thumb rule is that on either side from 15 kilometer the people will come. So, if you are providing a track here, the initial traffic will come from this 15 kilometer, and then slowly it will expand to 25 kilometers. So, this becomes the catchment. So, we need to find out that what type of development is there, accordingly people will be moving from those locations. Nature of traffic, whether it is a freight or a passenger, it all depends what type of area it is. Volume of traffic, it is going to be increased with respect to the square of the population. Again, this is a thumb rule, so as to get the demand which needs to be satisfied by this track. So, this is another thing you have to keep it in mind. The growth rates are the factors, they are to be discussed with respect to the population, with respect to development of the area, with respect to the production in that area. So, those growth factors also are required when we are interested to identify that what is the demand which needs to be satisfied by providing a track. Cost considerations, construction cost we have talked, but the material from where it is coming, the labor which is going to be available locally or it is to be brought from somewhere else is an important aspect. Operating cost, terrain considerations, connectivity with equitable reverse flows. So, these are few of the points, the economic considerations point of view, they are usually looked at. Then location of the station yards and the stations. This is also an important thing, because we need to know that there are so many problems. Say if we are talking about drainage, so there is going to be a problem. We need to look at the leveled stretches. We try to be a bit outside the town, on the periphery of the town. So, everything comes to that. So, there should not be a overlap, or there should not be a crossing with the local traffic. It should be free of that. So, some locational aspects with respect to the stations and yards also needs to be taken care of. Religious and historical monuments, in this case as far as possible we should not pass through them. One of the reason is the vibrations, and these vibrations which passes through the land to the any monument, it may be a detrimental to this because of the structure which is very old, and these vibrations which are coming may cause a deterioration here. So, as far as possible we should not consider them, but we can consider them from the tourist point of view. In that case, some bypass mechanism has to be taken care of. The economic considerations, though we have discussed, but just summarizing here, cost effectiveness, and cost effectiveness can be looked in terms of revenue, in terms of expenses, in terms of the investments. So, what is the total investment which is being done, what you are generating out of it in terms of say the freight movement or a passenger movement, and what are the various operational expenses which are there. So, on the basis of that we can get an idea about the annual returns, and this is one of the parameter in economic theories, so as to understand whether this connectivity is going to be feasible, viable in terms of economic aspects. Optimized operations and maintenance, if it is being done, then it is also going to reduce the expenses, and if it reduces the expenses, your annual returns will improve. So, with this we close our discussion now. So, what we discussed was that what are the requirements for an ideal alignment, what are the various economic aspects, how to improve upon the comfort and safety, and so as to do that, what are the various factors which should be taken into consideration when we are trying to select an alignment between the two different locations. With this, we close now. Thank you. We will be meeting in the next lecture.